Hi, I'm here with Sir James Hopwood Jeans, a modern physicist who was born on September 11th, 1877, in Omskirk, United Kingdom. Thank you for having me on. Good morning from my basement, even though it is 4:53 in the afternoon. You're wearing pajama pants. I am wearing pajama pants. Okay, so did you always live there? When I was a little youngster, we moved to Binghamton, and then a few years later, I was about 3, we moved to London, England. Yeah. What were your parents like? They were hella religious. My father, William Tulloch Jeans, he was a journalist, and he had 3 kids, oldest being me. I had 2 younger sisters. So what did you do as a kid? Actually, I had like a real interest in clocks. Clocks? Anyway, I was so passionate about clocks, I would dismantle them, and then boil them, and then reassemble them, and I even made a little booklet about it. Top read. Dork alert. Nah, I adored math and numbers. Okay, so where are you getting all these shirts from? Does anybody else notice this? Yeah, well, actually I was pretty shy as a kid. But I see that you weren't shy, you got married. Yeah, to this beautiful creature. That's a doll. Oh, my bad, this isn't my wife. Sorry. My first marriage, I was married to Charlotte Tiffany Mitchell. We had 1 daughter. We lived in America, then we moved to England, and also married, second marriage, to Suzanne Locke, and together we had 3 kids, and we also wrote a book together. Check it out. America, today I learned something about love. Only true marriages write books together. Anyway, did you go to college? Monsters University. It says here you went to Trinity College, Cambridge. Yeah, I majored in jazz hands. No, he majored in mathematics. Would you like me to tell everybody what year you graduated in? 1903. Now, did you continue your education? No, but I do have a master's degree. So where did you work? Oh girl, don't even get me started about that. Oh, I can feel the regret building up already. It goes like this. From 1905 to 1909, I was a professor of applied mathematics at Princeton. Then from 1910 to 1912, I was a lecturer in applied mathematics at my stomping ground in Cambridge. In 1923, I was elected associate research at Mount Wilson Observatory. It was pretty chill. Pretty awesome. Anyway, on the side I was the secretary of the Royal Society from 1919 to 1929. I was also the president of the Royal Astronomical Society from 1925 to 1927. I was also the president of the British Association for the Advancement of Science meeting in Aberdeen in 1934. And lastly, I was vice president of the Royal Society from 1938 to 1940. Kinda a big deal over here. Wow, that's very impressive. No. So what did you bring to the world of physics? You know, nothing that's really used today. It's not that great. Alright, let's hear them. Well, I did a lot of research on the quantum theory, actually. Quantum theory is a theory based on the concept of the quantum unit, something that is able to be measured as a quantum unit, to describe the dynamic properties of some atomic particles and the interactions of matter and radiation. Basically, there's my homeboy, Lord Rayleigh, and I. Back in 1905, we made something called the Rayleigh and James Law. No big deal, we have our own law. All attempts to describe the spectral radius, quantity of radiation that passes through or is transmitted from a surface of electromagnetic radiation at all wavelengths from a black body. Black bodies are bodies that absorb all incident electromagnetic radiation in temperature. However, the law only applies empirical measurements of low frequencies and not high frequencies. This did help, however, the development and further research of the quantum theory. And it convinced many to accept the quantum theory and actually do research. And great, what else you got? Analyzed the breakup of rapidly spinning bodies under the stress of the centrifugal force, and concluded that the nebular hypothesis, which the stars and the planets condensed from a single gaseous cloud, was actually invalid. Anyway, I proposed the tidal theory because, I can. Tidal theory was when the stars almost collided with the sun, and bypassing cellular debris, condensed and made planets. Yeah. Also, you made Jean's length. Sure did. Jean's length is a critical radius of interstellar cloud in space that depends on three things: temperature, density, and mass. Anyway, I came up with this thing called Jean's instability, which solves for the mass a cloud must attain before it's able to collapse. I'm very impressed, and I also heard that you investigated stellar nebulas, the source of stellar energy, binary and multiple star systems, and giant and dwarf stars. Yeah, a little bit. So did you write any books? Yeah, I wrote these. That's a children's book. Nuh-uh. I wrote a bunch of books. I wrote The Dynamical Theory of Gases, published in 1904. Theoretical Mechanics was published in 1906, and it was a textbook. I also published another textbook called Mathematical Theory of Electricity and Magnetism in 1908. I wrote a report on the radiation and quantum theory, and it was published in 1914. Problems of Cosmology and Stellar Dynamics was published in 1919. Astronomy and Cosmology in 1928. I published Science and Music in 1938 with my wife, Suzanne. Didn't we, Suzanne? Yes, we did. Oh yeah, you're not my wife, sorry. Love you, Suzanne. Physics and Philosophy in 1942. And lastly, The Growth of Physical Science in 1947. Wow. Yeah, So, last thing, do you have any awards? These? I thought you'd never ask. Those are soccer trophies. So they are. Well, in 1906, I was selected for... In 1919, I received the Royal Medal of the Royal Society. In 1922, I got the gold medal from the Royal Astronomical Society. Oh, I was knighted in 1929, no biggie. And I got the Adams Prize and the Hopkins Prize of the Cambridge Philosophical Society. I forget when, sorry. Dead people problems. Wait, what? Woo, I'm a ghost. How the... did you die? Back in 1946 because of a coronary thrombosis, do y'all feel? No, I do not feel. This was a mistake. I'm done. Well, this concludes my interview. Have a great night, y'all. So, we're going to take a look at some of the things Sir James Hopwood Jeans did. Okay, so first I'm going to talk to you guys about the quantum theory. And so the theory is based on the concept of the quantum unit, which is something that is able to be measured, quantitative. To describe the dynamic properties of subatomic particles, which are elementary and composite particles, and the interactions of matter and radiation. However, the law only applied to lower frequencies, and it failed to fit empirical measurements for the higher frequencies, or ultraviolet and catastrophe. Yeah. It's a lot of work, isn't it? Anyway, this blue line represents the theory of, the other line is prior theories. This was kind of all their work, and this is what they got to. Anyway, then he made this thing called the Jeans length, which is the critical radius on interstellar cloud in space, which depends on temperature, density, and mass. Here's the equation for it. He also had another thing called Jeans instability, which solves for the critical mass a cloud must obtain before being able to collapse. Okay. He also had one last thing. It's called the catastrophic end tidal theory. Pretty much, Jeans was analyzing the breakup of rapidly spinning bodies under the stress of centrifugal force, and concluded that the nebular hypothesis, which are the stars and planets condensed from a single gas cloud, was invalid. He proposed his theory and said that the stars narrowly missed colliding with the sun, then proceeded to draw away. In the passing, stellar debris condensed to form the planets. That was also proven invalid later.